All right, this is the beginning of Unit 8, and this is the lesson on the average value of a function. So this is basically also called the mean value theorem for integrals. I often just call it the average value of a function and the mean value theorem for the derivative one, just to further make it easier. It is actually related, but this is the physical concept that we have here. So if you have some sort of curve that we're trying to find the area, if we take a inscribed rectangle, which is the first figure with the purple one that's underneath, and use it, say we approximated the area, and then if we take a circumscribed one, so that's the biggest rectangle we can draw and conclude a point, that's definitely more than the actual area. So the mean value theorem for integrals basically just says somewhere between those two things, there is a place where we could draw a rectangle, the pink one. We could draw this perfect rectangle that would be exactly the area of underneath that curve. It would be equivalent to that. And so the theorem guarantees that there is at least one place on the curve where if we drew this rectangle, we would get that exact area. So, and then again, we just call that at C. So we're guaranteed that there is at least one place C that gives us exactly that rectangle is exactly the same as the area under that curve. And so looking at the theorem a little more formally, it says, again, if f is continuous on the closed interval, remember that a lot of our theorems, most of them, it's got to be continuous. So we need to check that. As long as the function is continuous, then there exists some number c in the interval from a to b, so that's an x value, such that if we integrate from a to b of f of x, we would get the function value f of c, okay, which is this point, so this is our c. If you take that function value, so that's the length of that dotted line, times this b minus a, because we're going from a to b, times that length, that's exactly what you're going to get for the curve, underneath the curve. So again, it's not telling us how to find c, it's just guaranteeing that there is one. Okay, so it's just an existence, it's not telling us that. Now, what we will use it for is we'll kind of rewrite something to talk about the average value of a function. Now, this is where a lot of students get really confused. So this is really, really important to pay attention here and really say the right words to yourself. If I ask you to find the average value of a function, so a question says, find the average velocity of a function, and you have the and then you're going to integrate it. If I want the average rate of change, that is still going to mean to find the slope of the endpoints. That's never going to change. So here we've got to pay attention if it says average value, and value might be whatever the units are, okay, whatever the problem is talking about. Average value on a function. So basically we just sort of solved that other equation, and so we divided by the b minus a. So this is a formula that you definitely need to have in your composition book. So I would have a page called the average value of a function on an interval, and I would write all of this, and I would have that written down, because you're going to be asked it all the time. Okay, you're going to be asked all the time, find the average value on this interval. So essentially what you're doing is, it's like you're finding, this is a way you can help yourself remember it, this is the area, and then I'm dividing by the width of the interval, so it's like I'm finding the average height, the average of the area, okay, so I'm finding the average value, okay, so that's what another way to kind of think about it. And so it can also be written where you literally just write the integral over b minus a, and it equals f of c. So again, it represents the height of that rectangle for that mean value theorem for integrals. Okay, so mainly we just need to be able to use it. Find the average value on the interval from 1 to 4. So when I see that question, the first thing I'm going to think is average value means 1 over b minus a, integral a to b of the function dx. So for this problem, that's going to be 1 over 4 minus 1 integral 1 to 4 of 3x squared minus 2x dx. And so I'm just going to integrate that and finish the problem. So I have 1/3 on the outside. I'm going to go ahead and do my antiderivative. So I'm going to have x cubed minus x squared, and I'm going from 1 to 4. So I'm going to have 1/3. And then I'm going to plug in. So I'm going to have 1/3. I'll have 4 cubed is 64. If you don't know what it is, just write 4 cubed. Minus 4 squared is 16, minus parentheses, and then you need to plug in 1 for both of those. And like I said, when you're plugging in for that second part, I would literally go ahead and always actually do it so you don't end up thinking there's never an answer there. But I have 64 minus 16 over 3 is going to be my answer. And 64 minus 16 would be 48, and that's going to simplify to 16. And remember that if this was a free response question, this is absolutely where you end. Matter of fact, I would even just leave this 4 cubed minus 4 squared. I wouldn't even mess with it, and I would just leave it. But on your homework, you do need to practice and go all the way to this answer so that you can match it to questions that you have. Okay, so you do need to practice because you need to practice your arithmetic. But when you get a free response question, absolutely do the least amount of, just as long as you have all numbers in, you're good. Now part B says find the value of C guaranteed by the mean value theorem for integrals. Okay, so this is saying mean value theorem of integrals says if I integrate from 1 to 4 of the function, then I'm supposed to get f of C times b minus a, which is 4 minus 1. And so I can solve. Well, I just did this integral on the left. That was 48. Because I did 48 and then divided by 3, right? If you go back and look, right, this 1/3 part came from this dividing. So the 48 was the value of the integral. And that's going to equal f of c times 3. I'm going to just move that 3 in front. So you're going to get 16 equals f of c. Now, I could have also figured that out, like I could have, instead of writing it this way, I could have just written 16 equals f of c, because remember, that's what it tells us. But if you want to practice with the formula, or we could have written this, and I'm not done yet because I haven't found c. I could have just written from this step, or actually from the beginning, I could have just written integral 1 to 4 3x squared minus 2x dx, and just went ahead and written the 1 over 4 minus 1 is going to equal f of c. So then I would just know it was 16 equals f of c. Okay, so that's another way to do it. But I'm not done because that's f of c, and it said what value is c. So my function f of x is called 3x squared minus 2x. So I'm going to put a c in there because I'm trying to find out when does f of c equal 16. So this is what I'm trying to figure out. What is c? So I plug c in for the function, and then I need to solve it. So I have 3c squared minus 2c minus 16 equals 0. This is, of course, a quadratic. I need to factor it. Remember how factoring needs to be second nature. So I'm going to go through the factoring here, but if you want to, you could pause the video, then you factor it and make sure you know how to do it. So that's a very good suggestion. We're going to need factors of 3 times negative 16, which is negative 48. This is my scratch area over on the right. And I need the sum to be negative 2. So I can figure that out pretty quick. It's going to be 6 times 8, and the 8 will be the negative. But if you need to, you write out all the factors until you figure it out. Then remember, we know 3c squared has to be 3c times c, because I'm only using integers. And then my outside product, 3 times something, is one of these numbers. So I have to be making the 6. So 3 times 2, which leaves negative 8 there. So if you need practice with factoring, again, I would suggest doing it. So then we have two answers. C is either 8/3 or negative 2. But then we need to pay attention. We are finding the value from, on this interval, from 1 to 4. Okay? So if we're between 1 and 4, negative 2 does not work. So this is the only answer for our question. It's just like the mean value theorem for derivatives. You may get more than one answer. You can only give the answer that's in the correct interval. So make sure you pay attention to that. Okay, let's look at this. So this will be a calculator problem. So we'll just basically write down what we need to do, put it in the calculator, get our answer. So remember, that's how we need to do calculator questions. Practice, practice, practice. So in the year 2000, the world's population was 6.1 billion. Relative rate of growth was 1.4% per year. So then they give you a function that models that situation. N is people in billions, and T is the number of years since 2000. So assuming this continues until 2050, find the average population of the world between the years 2010 and 2020. And then you got to figure out your units. Okay, so average population. That means average value, because the function we have is population. So I want the average value, but again, often they use the word that is the unit that we're talking about. So population, okay? So average population. It does not say average rate of change. This is not to do a derivative, and it is not to find the slope. It says average population, so average value, okay? Average value. So it's 1 over 2020 minus 2010 times the integral, or actually T is the number of years since 2000, so we're only using 20 minus 10. The interval, then we're going to integrate from 10 to 20 of this function, 6.1 e to the 0.014t dt. Okay, so this is what I write because it's a calculator question, so I have to say what I'm doing. So average population, again, this function is population, so I'm finding the average value. That tells me to do the 1 over b minus a, integrate from a to b function. Okay, then I will put it in the calculator, and you will get 7.5315. I'm not going to do that on here, but you should certainly get your calculator out and practice, especially if you struggle at all with the calculator. Then I have to answer the question and make sure I have units. So basically what I found was the average population of the world between 2010 and 2020 is approximately 7.532 billion people. Make sure you don't say 7.532 people, because obviously it's a lot more than that. So again, with lots of stuff, go back, read the question again, really understand what out of that question told me what to do. Make sure you practice it with your calculator if you need to. All right, example 3. So here we suppose that C of t represents the daily cost for air conditioning in your house in dollars per day, where T is the time in days, T equals 0 is July 1st, 2017. Explain what the following things represent in real-world terms, including the units. Now remember, this is a very important part of calculus test. You have to be able to interpret, okay? And if you can interpret, you could also write them if you needed to write them, if you knew the interpretation. So, first one, A, we're going to integrate from 0 to 90 of C of T. Well, C of T is dollars per day, and I'm going to integrate it, which means that I'm going to have total dollars, okay? So that means this would be the total cost in dollars to cool your home. And make sure, remember when we interpret, we have to have units and over an interval of some kind. So to cool your home, and it would basically be July 2017 to September 2017, or you could say, for example, from 90 days from July 1st, 2017, okay, for the 90 days after that. But you have to say when it occurs or it's not correct. Okay, B. Well, if this part is the total cost and then I divide it by 90 days, then I now have dollars over days again. So that means this is the average cost to cool my home in dollars per day, right? Because I integrate, I got dollars. So now I'm integrating, but then I'm dividing by days. So now I have an average cost. So instead of writing average value, I will say average cost, because that's what the function is talking about. It's talking about cost. So I will say average cost to cool your house in dollars per day. Be sure we have units. And here's a different way we could have said the same thing over here, for 90 days from July 1st, 2017. So that's how I could say the same thing too. I could have just said cool your home for 90 days from July 1st, 2017. So on the first one. So that's just giving you two different ways that you can sort of say that, okay? All right, so now let's talk about the Supersonic Man. And this is the last example that we'll be doing, so that'll complete this. So on October 14th, 1947, Chuck Yeager flew his X-1 rocket plane at an altitude of 12.8 kilometers. He was clocked at 299.5 meters per second, and that's about 669.962 miles per hour. At different altitudes, sound travels at different speeds. We can model this variation for speed of sound with a piecewise defined function given below. Okay, so this is the piecewise function. So again, sound travels differently at different altitudes. So first thing it asks me to do is to integrate the function from 0 to 80 using 5 subintervals. Okay. So the way we're going to do A, and I'm going to do it right here because we have the problem still here so you can see. So this is part A. So to integrate this, you can't just integrate 0 to 80, obviously, because it's different functions for different parts. So basically, I'm just splitting it up. So I would integrate from 0 to 11.5 of negative 4t plus 341 dt, and I would get an answer. And then I would continue to do that. So I'm just going to go ahead and write each individual answer down, and then my overall answer would be to add them all up. Then I would integrate from 11.5 to 22 of 295 dt, and of course I'd just be doing all this on the calculator. It's 3097.5. I can integrate from 22 to 32 of the next equation. And And of course, if you want to practice in your calculator, this would be good practice for that. And then I have to go from 32 to 50. And then I use this equation. Again, I'm looking up here. I'm just using the equation over the interval that I'm at. And that's going to be 5, 6, 8, 8. And then I integrate from 50 to 80. Negative 1.5t plus 404.5 dt, and that answer is 9210. So basically, if I want the answer for the integrating the entire function, then I would add all of those numbers up. The alternate way I could do this, if this was on a test, I could literally just write that the integral of s of t is integral 0 to 11.5 negative 4t plus 341 dt plus integral 11.5 to 22, etc., etc. It's whatever's easiest to you, but then the answer for the entire integral, I would add all of those up. And I'm not going to do that because we're going to see on part B how we can kind of use that. So part B says, apply the mean value theorem for integrals to find the average speed of sound. Well, what that means is I need to do the entire integral from 0 to 80 of s of t dt and then divide it by 80. Well, what that means is I would actually be doing the integral from 0 to 11.5 of that function dt plus the integral 11.5 to 22 of that function dt, etc., until I added them all up. Then I divide the entire answer by 80. That's what's really important. You don't find the average value of each individual integral, and then when you're done, add them all up. You find the entire integral and then divide by 80. So in my case, I'm just going to use all those numbers I wrote down for each of those intervals. So each integral, I have each of those values for all 5 of them. I would add all of those answers up, get the entire answer for the integral of s of t, then I would divide by 80. So that's kind of important if you're doing the average of something that has different parts. You have to find the integral of all the parts, add it all up, and then divide by the entire interval of the entire thing. And then if we were to simplify this, this would be 308 meters per second, or if you just want to know, the average is 688.976 miles per hour, just for reference. Okay? So a lot of that's just arithmetic stuff, not that big of a deal. Then it says on part C, draw the average value S of C on the graph. Okay? Well, the average value was 308. We just did that, 308 meters per second. So basically, that's this right here. Okay, oh, that kind of went crazy. That's about right here, so that's 308 meters per second. And what that means is that's the place where if I draw a rectangle, if I were to go from 0 to 80 and draw the rectangle, that would have the same area as I get when I add up everything underneath. Okay? All right, so that's it for average value. Biggest thing is understand average value is not the same as average rate of change. Average value means to integrate and divide by the interval. Okay, so really important. So make sure you update, put a page in your composition book because it's super important. It's definitely on the test multiple times. And then any practice you need with your calculator, this is a good time to do that.